Nous allons enchaîner tout de suite avec la nouvelle session sur les déchiffrements en cours. Et j'appelle tout de suite Silvia Ferrara de l'Université de Bologne. Merci, sur les déchiffrements des écritures égéennes.
Merci à vous pour votre attention. Je m'excuse, mon français est terrible. Je vais parler en anglais. I'm so happy to have been invited to this conference that marks a special year for all of us. And not only all of us gathered here who are, some of us, most of us, specialists, but a broader set of listeners and readers and students and thinkers. Because trying to decipher an ancient script is a process of thinking, of methodological thinking. Intuition, we've seen with Champollion's éclat, plays a part, but it does play a part very rarely. And it can play a part only after the studious application of a scientific method has been totally exhausted. I lead a research team whose activity pivots around understanding how writing was invented in the world, how many times, and from what stimuli, from what underlying iconographies. And this is called Inscribe, Inventions of Scripts and Their Beginnings, and it's an ERC-funded project. What we seek to do with Inscribe is not only to frame the invention of writing from a multidisciplinary, I should say transdisciplinary perspective, which encompasses linguistics, cognitive science, to understand how and why shapes of signs look the way that they do. And we also use state-of-the-art technologies, but we also, and this is very important, try to apply decipherment techniques to some of the ancient writing systems whose languages today are still completely unidentified. As you will know, up until recently, I would say a generation ago, Mesopotamia was taken as the homeland of writing, the only homeland of writing. Writing was invented there and only there. Now, our vision has changed quite a lot after about 30 years, and we can see 4 different and separate scripts that were created, invented from zero, with no external influence. And as you may know, these are China, Mesoamerica, Egypt. There's a lot of debate. This is not a plain and simple topic. And of course, Mesopotamia. So 4 of them. It means that human beings got to the invention of writing more than once. But other inventions across the globe are possible. One is in the deepest recesses of the Pacific Ocean on Easter Island, and we're actually working on this, and we made a little bit of progress. And the Indus Valley script, which is, a hotly debated topic. Is it writing? Is it not writing? We could discuss this for hours, but I don't have the time. So the exact number of the inventions of writing in the world is very uncertain, very dubious, and I think it takes a transdisciplinary team to tackle it. But, what we try to do with Inscribe is also to tackle a specific problem related to undeciphered scripts. And this is related to the earliest writing in Europe from the Aegean, from the island of Crete and from the island of Cyprus. And believe it or not, there are about a dozen ancient scripts that are still undeciphered, and no fewer than 3 come from the Aegean. The Aegean represents the least understood family of scripts in the world. So, as you can imagine, this is a daunting project. And this is a daunting perspective to tackle decipherment. The 3 undeciphered writing scripts from the Aegean are Cretan Hieroglyphic, Linear A, and Cypro-minoan. Cretan Hieroglyphic and Linear A come from Crete, and Cypro-minoan comes from the island of Cyprus, although we have some inscriptions from Ugarit in the coast of Syria. And today I really want to talk about the progress we have made in shedding light on these 3 scripts. But before I do so, please do note what we have. We have very few inscriptions and very few signs. We're talking about signs in the low thousands. We are dealing with really small data, but I shall not be daunted by this, and neither should you. This family of scripts has a very notorious black swan, which is the Festus disc, you may know it, and this is one of the scripts that we cannot at all decipher. This is a unique object. We have only this specimen, and it's written, it's inscribed on both sides for a total of 244 signs. It's actually stamped. This is the earliest stamping process in the history of epigraphy. Black swan, we can't do anything about it. It's an unexpected epigraphic item in this family of Aegean scripts. So we should leave it aside as an oddity, as an idiosyncratic specimen that we cannot really apply the scientific method upon. And on the other spectrum, as you heard this morning, we have Linear B. Linear B was deciphered, as we heard, by Michael Ventris in 1953, and this was done through a thoroughly internal process of decipherment. It means that we had no bilinguals, we had no external evidence, he had to work basically on only the data at his disposal in terms of Linear B. And this is an important point because it's got to do with method. And before I talk about the results of Inscribe, I really want to stress how method is important. Decipherment is a big word, and we should be really, really cautious in using it unless we have external evidence and unless we can pinpoint and validate results through the scientific method. So we have no bilinguals. We have no external evidence. We can only rely on a methodological internal reconstruction. And this, when it comes to the undeciphered scripts of the Aegean, is what I think the architecture of decipherment, as I see it, should be, at least in relation to the three scripts that I talked about. Especially with the first script, the one that is image-based, the Cretan Hieroglyphic, the name gives it away. For a long time, it was thought to come directly from Egyptian hieroglyphic, but hieroglyphic is really a definition that comes from the shapes of the signs, which are highly pictorial, they're image-based, they're highly iconic, one could say. And this is clearly the case. We are dealing with a script that is totally figurative. So the first thing that one needs to do when it comes especially to a script that has an interface with art, that has an interface with images and symbols and what could come across as decoration, is to identify the individual signs in the repertoire. That is to assess the inventory, the sign list of the signs. This is very difficult when you have an image-based script. And believe it or not, for the Aegean scripts, except for Linear A that we will see, this has never been done. Step 2 entails identifying the position of each sign within a word sequence. And this is, again, a very crucial step that was fundamental for the decipherment of Linear B. This was, I would say, the key point of Michael Ventris's internal method. He gauged where each sign was within a word. And step 3 is related to the patterns and the schemes of grammatical features. If these are available, we need to have repetitions for that to see whether possibly a morphology is inflected or not. Step 4 entails a network analysis, and this is my own proposition, across the typologies of inscribed objects and the archaeological context. I think this was mentioned today. It is a crucial point because it helps us to gauge possible subject matters of the text. Basically, it helps us to understand what topics the actual inscriptions cover. And as you will become apparent, this is a very fruitful endeavor when it comes to the Aegean scripts. And step 5 seeks to reconstruct the epigraphic tradition, and this can be done with the Aegean scripts. The lineage, the sort of, diachronic perspective to see whether we can have continuity in the sign shapes, and then decide whether we can apply phonetic values. But this architecture is really the basic substratum that we need to use before we can attempt to apply, to even dream of applying phonetic values. So it's crucial that we set an agenda that's consistent throughout when it comes to building an architecture around the script. And what we did with the Cretan hieroglyphic script had never been done before, and had never been done before systematically. What we did was try to frame it, because there was this idea that it came from Egyptian hieroglyphs. So even Evans, that discovered the earliest inscriptions in Cretan hieroglyphic, had this kind of, suggesting hypothesis that it came from Egyptian hieroglyphs. But we had to frame sign by sign contextually vis-a-vis the Egyptian hieroglyphic. And the idea ever since has been that unless you do a systematic analysis sign by sign vis-a-vis Egyptian hieroglyphs, we cannot have any possible idea as to the origins of this script. And what we did is that the script is less and less derivative from Egyptian hieroglyphs than scholars thought from the very beginning, ever since Evans. That however much the exposure to Egyptian, I'm sure that the Cretans had exposure to the literacy of Egypt, this was never a template that the Cretans borrowed wholesale. In other words, this script is in shape, and I don't know about sound, but in shape, it is new. It is invented ex novo, if not ex nihilo. The individual signs are original, and they look original. This is a very important result, but we wanted to push the agenda even forwards, going back, to reach at least step 1 in our attempt at decipherment, to build the sign list. So what we did next is to do a systematic rationalization vis-a-vis the pre-existing iconography, the preceding iconography on seals, and we proposed a standard sign list. This was incredibly, after 120 years, a grave desideratum in the field. But, one has to relinquish hope when one must. Cretan hieroglyphic cannot be deciphered today, but some of it can be read. And this means that we can apply a few tentative phonetic values to its signs. This was not done through only an analysis and a comparison with linear A and linear B. This was done afresh, autopsying, going to Crete and analyzing each inscription as much as possible. And what we did was, again, had never been done before. We created a digital database using 2 scanning techniques in 3 dimensions. You just saw one linear A item that was made, whose 3D model was made through using a scanner and using also photogrammetry. So we juxtaposed photogrammetry onto the 3D scanning, and we created what is called baking. It's called baking technique in order to create the 3D models. If you actually point your smartphone onto the QR code, you will see all of our 3D models for the Cretan hieroglyphic script. And you will see, if you do, I see nobody's doing it, but I will show you examples, you will see how we can look at the inscriptions in all the nooks and crannies, in all the idiosyncratic details so perfectly that this enabled us not only just to see the sign perfectly, but to correct several readings in the copied extant catalogues, which are just books, they're not digital. Again, this had never been done before. We need to finish our job, but it's still a work in progress, but we've done tremendous progress in that direction. So seeing the objects perfectly I have to say, made us career into progress quite quickly. And I'm turning to the first results we achieved in relation to the Minoan script of the 2nd millennium BC on Crete, linear A, which comes directly from Cretan hieroglyphic. And this was what Stephen Houston called a revolution, because in a very few intense months, we solved one of the still standing enigmas of linear A, its system of fractions. Linear A is a close descendant of Cretan hieroglyphic, and it can be to an extent read through the backwards application of the phonetic values of linear B. But the syntax is very terse. The texts are very concise, so they do not allow us to understand or identify the underlying language. Linear A was an instrument of the internal bureaucracy of the Minoan palaces, and it has no narrative, no long text, no syntax to speak of, but it has fractions. And the mathematical values of these fractions, again, for 120 years, were, for the most part, a mystery. And it is a mystery that we tried to solve with, I think, a high degree of probability. What we did in this respect was use not just paleography, not just epigraphic analysis, but new technologies. Well, this one is not that new, but it had never been applied to the Aegean scripts. Constraint programming. We knew that linear A fractions worked in combination, so that we had on several tablets sums of two or three fractions, and they were put in descending order. Say a bigger fraction was followed by a smaller one. And we determined the variables and the possible combinations in the usage of these fractions, excluding the ones that were impossible, that didn't quite add up. Since at the end of this manual and logical patterning, we used paleography just for that, we were left with many possible solutions, about 4 million solutions. And we created some measures through computer science to rank the results by quality and select the only possible and sensible solutions. We also used analogical analysis, checking all the ancient fractions ever used in ancient writing systems. And in this way, by trial and error, by exclusion, by constraint, and through a combined methodology that married paleographical analysis, paleographical work, and computational approaches, we achieved the mathematical values for all of the fraction signs, so that we can now identify 1/2, 1/3, 1/4, and so on, and we perfectly know how they worked. I'm waiting to be rebutted on this, because ours was just a proposal. I don't go as far as to say that we deciphered, but we got really close, and if anybody has a better solution, I am super happy to hear it. Our results came out in the Journal of Archaeological Science. We had so many reviewers that it was quite funny to go through the rebutting, but it was one of the most downloaded articles of 2021, and I'm so pleased that my team worked with engineers, computer scientists, paleographers, and linguists together. And now we come to the most complicated script of the Aegean, Cypro-minoan. You can see here some 3D models of the inscriptions, and they're actually housed here in the Louvre. I am so grateful that we could create this, and I would like to shout out to Ariane Thomas, Véronique Patay, and Mahmoud Alassi for all the help and patience and all the hard work that we put in together. Cypro-minoan, you see the texture baking there. We have both photogrammetry and 3D scanning together. We can see, these are really tiny objects. The one that you saw just before is a very small cylinder seal, and we can see the signs perfectly. Cypro-minoan was a script used on the island of Cyprus during the Late Bronze Age. It directly derives from linear A. But its graphic repertoire, its sign list, was modified to the extent that only through a systematic paleographic approach we could reconstruct the lineage from linear A. This was an open question. Does Cypro-minoan come directly from linear A or not? This took us years of work to achieve, and we have also tackled another huge problem in the study of this script. And I will try to explain, although it's quite technical, I will try to explain to you what this is. You can see a clay ball, it's as small as that. I will go very, very fast. For many years, the script was divided into 3 sub-branches, each allegedly recording a different language. The idea was that some of the signs were not present in one branch, but they were present in another, and some were attested in all 3. This begs the question, was it 3 scripts recording 3 different languages? And this very lack of homogeneity led scholars to suggest exactly that, 3 different scripts recording 3 different languages. I had many suspicions about this. You must remember how few inscriptions we have in Cypro-minoan, about 300. The likelihood that some signs not being attested homogeneously was already high. To this, we need to add the sheer variety in inscribed objects. You see there are 3 tablets, but there are so many different varieties, typologies of different objects that were inscribed. It was incised on metals, inscribed on moist clay, on a few tablets, as you see, painted on vases, engraved on ivories, the whole lot. So the shapes of the signs vary a lot when the epigraphy is so diverse, so typologically different. An incised sign will look very different from a painted one. But if I claim as much, I push the agenda. I make it subjective, and to an extent, I may come across as biased. So we let the computer do the talking in order to test this. And what we did was use an unsupervised deep learning approach to learn a vector representation for each sign. This means that we did not suggest to the computer anything. We gave no labeling, no indication as to what signs were represented. The computer managed quite simply to separate the vectors of signs inscribed on clay tablets, and note importantly that what we have is that the tablets run across 2 sub-branches. They are found on 2 groups. So what we did in order to test this was to show that the tablets and the tablets go together, and the signs inscribed on other epigraphic supports are separate. It's as if the computer understood that there was a clear epigraphic distinction that made the signs more distant paleographically than they are, and according to the type of objects they were inscribed on. So I wanted to show you how we created this scatter plot that shows you how the unsupervised deep neural network clearly separates the signs inscribed on tablets, which are the ones in the green, and the signs inscribed on all other objects. And this was done suggesting nothing to the computer. In other words, the computer understood that all the tablets which belong to 2 different scripts are to be bunched together. And this is quite astounding because it tells us that there is an epigraphic bias, that the actual signs change and variate in accordance to what inscribed object we have in front of our very eyes. But we can take this even further. You may remember, I need to move, in the internal decipherment method that I had outlined before. The network analysis. We created a network analysis for Cypro-minoan correlating repetitions. We are quite lucky, we have repetitions in Cypro-minoan of short inscriptions on different inscribed objects, and made pilot studies geared towards reading the script. I'll give you just one example to be quick. We were able to map repetitions in Cypro-minoan across different objects. What you have here, for instance, is a very small, tiny clay ball, a cylinder made of ivory, a cylinder made of clay, and an ivory pipe. And these quite likely identify proper names. the sequence that you find there is more likely than not a proper name. But we also can put these names on the archaeological map. Step 4, these names come alive in the daily life of the ancient Cypriots. And in this case, they're active in the religious sector. We know that these signs are repeated only in the religious sector. And with Miguel Valerio, who was part of the inscribed team, we have possibly identified high-status personnel involved in the religious sector. We've also identified the function of the clay balls, but we can talk about this at discussion. So we have mapped all of the repetitions across the 300 inscriptions and have identified a number of personal names inscribed on high-status objects. And this has enabled us to build a hierarchy of important personnel, in this case active in the religious sector. But there is more. And in the last 4 years, we have advanced a lot in reading this script, thanks to the work of Miguel Valerio. We can suggest possible phonetic values. And we have found one sequence, this is tantalizing, just to give you an example. Amotaro, which can be correlated to a name found at Ugarit in the archive of Rapanu in a letter of the king of Ugarit. And Rapanu was just not a simple man. He was a high official and merchant who held the correspondence with Cyprus, believe it or not, and in whose archive we also find an intact Cypro-minoan tablet that you see over there. Is this a coincidence that Amotaro may be in both sides, on Cyprus and Ugarit? And is it a coincidence that we're talking about a high-status individual? Is it the same man? Maybe he is, maybe he's not, but tantalizing suggestion. And in conclusion, going back to our architecture of decipherment, inscribe for 3 scripts that represent the least understood family of undeciphered scripts in the world, made, I think, you may disagree, but made quite a little bit of progress. We established signaries, sign lists, and we characterized them. We applied multi-stranded methodologies that seemed to work. And we got to tentative readings, and we solved a few dilemmas. The path is still open for more progress, of course, but I hope I've showed you the resigned stance that I found when I started working on these things, which Aegean scholars were grappling, can be overturned by embracing daring trajectory of research and analysis. And don't go and study Maya with Stephen Houston. Come and join us to try and crack as much as we can. And before thanking you, I would like to thank the whole Inscribe team, most of which is present here today. Thank you, guys. To Inscribe researchers, past and present, my deepest gratitude. You're great. And thank you so much for listening. Merci à vous.
Merci.